Before getting into the technicalities and the applications that run penetration tests, I'll take you through a quick overview on the applications and the layout of the Kali desktop. So if you go here to the applications menu, you'll see that as we said, that we have more than 300 applications used for penetration testing, security auditing, forensics, etc. These 300 applications are well spread over these categories of information gathering, vulnerability analysis, web application analysis, database assessment, password attacks, wireless attacks, reverse engineering, etc. So it's now easy to spot an application directly under the category of attacks that we are planning to do. We'll go into the details during the course. Here, if you press on the places, it's actually file manager, simply as in Windows, just by double clicking folder, you can go there, you can see the desktop, documents, trash, which is the recycle bin. So it's a simple file manager. Here is the calendar, and here are the workspaces. The concept of workspace is really important, especially if we're planning to do multiple or running multiple applications. So for example, if I have this terminal open here and I have maybe other applications, this is in workspace 1, I can go to workspace 2 and open other applications without even closing or disrupting the initial applications open. So this is a very nice feature in Kali. Here you can see the wired connection, wireless connection maybe if there is any, but the virtual machines usually cannot access the internal wireless card here. I'll show you later on during the wireless attacks how to set up this. You can as well turn off the machine here, lock it, and go to the settings. So feel free to just explore desktop environment.
If you need to have a successful exercise of penetration testing, you need to have a plan in place. Now we're gonna talk about the phases of a successful penetration test. And there actually generically are 5 phases, because on the internet and on many different resources, you can see that these phases can be 5 or 6 more or less. The first phase is called reconnaissance, then scanning, then exploitation, maintaining access, and then reporting. So on the first phase, which is the reconnaissance, actually the attacker tries to gain information about the target. This approach can be active or passive. The attacker tries to have a blueprint of the security profile of the target, whether it's an organization, a person, etc. So it involves gathering information about the network that we are attacking and attempt to create a profile of the organization's networks, systems, and applications. Some of the most common tools used in the reconnaissance phase are the Whois utility or smart Whois and the NS lookup. You can as well use open information which is available on the internet, such as the contact names of the company, available phone numbers, email addresses, locations and branches, even the partners that the company has relation or deals with. You can as well check the news about some mergers, acquisitions. The website of the company is very important. Some links on this website which might take you to the company's policies and procedures. So it's utilizing the open source data available. The second phase is scanning, and here our goal is to discover the open ports, the available access points, the operating systems that are used, and to uncover the services available to us. The second phase is the scanning phase, and our goal here is to discover the open ports, access points, operating systems, and uncover services running on these ports. Our goal is to perform some external and internal scanning, ping machines to determine network ranges, and to come up with a profile of the individual systems. Some of the common tools used as well are the ping, traceroute, superscan, netcat, nmap of course, and others. Enumerating is an important aspect of this phase. The goal of enumeration is to paint a fairly complete picture of the target. So to enumerate a target, a tester tries to identify valid user accounts or poorly protected resource shared, some using directed queries or active connections from the target. The type of information sought by testers during the enumeration phase can be usernames, groups, some network resources and shares and applications. Some of the tools used in this phase or subphase, as we're talking about enumeration, are Active Directory lookups to uncover any vulnerabilities in users and groups, discovering the NetBIOS name with NBT scan. We will see this in the upcoming videos. Using SNMP util for the SNMP, and employing Windows DNS queries, along with establishing some null sessions and connections. The next phase is exploitation. Here, the actual penetration takes place. I didn't list the tools because they are all the tools available on Kali Linux, as we saw before in the videos. Maintaining access is to make sure that we still access the target. The last phase is reporting, which is the most dreaded part. It usually contains an executive overview and technical summary, but we need to get used to documenting our work and findings. It's the only professional way to get the job done.
Threat modeling can be understood as making sense of the complexity of the system we have at hand, whether it's a mobile application, web application, or even a network, and then by identifying all the possible threats it might face, and then by assessing those threats. In simple terms, it's about finding different ways in which our system can be attacked and subsequently designing countermeasures to stop these attacks. Threat modeling helps us become more proactive and strategic in our operational and application security. The ultimate goal is to reduce the attack surface and focus on the investment of the business itself. It actually starts by a couple of questions. What are we working on? So we have to identify the assets, and then what can go wrong? So after identification of the assets and having the architectural overview of the system, we ask ourselves many questions. How can the system be attacked? What can go wrong? So we need to pinpoint those questions. After that, what can we or what are we going to do about it? So here we start thinking of the countermeasures and the controls we will have in place. And at the end, we need to assess our job. Did we do a good job? Threat modeling actually springs from the trivial risk assessment model. We need to identify threats in the first place, whether it's process, it's a software, it's an attacker, anything can be a threat. The threat can attack our systems by taking advantage of weaknesses we have or vulnerabilities we have, and the purpose of threat modeling is to close the gaps of these vulnerabilities, is to put controls in order to close those vulnerabilities. So why threat modeling? Here are some of the benefits of threat modeling. It helps us identify and investigate potential threats to our system. It helps us understand our vulnerabilities. It helps us identify the logic between our system, how data flows, how instruction flow. It helps us create a set of standard documents that can be used to create specifications. So it's about systems and documenting the workflows and understanding our systems better. It helps us eventually in reducing the attack surface, reducing the threats, and closing and fixing many of our vulnerabilities. And of course, it helps us define the overall security posture of a system or an application. Different methods and techniques are used by pen testers, by practitioners, by analysts to understand the variety of information security risks. Some of those structured threat modeling techniques are attack trees, stride method, elevation of privileges, TMAP, PetriNet, data flow diagram, activity diagram, and risk reduction overview. Some of the most famous models is the stride model. So after having the architecture overview or after simplifying our process or system and projecting it on a diagram, we start thinking about what can go wrong. How does this web application or a mobile application workflow goes? Do I care about what can go wrong with this application? For example, does it have financial information information? How about the content of where is the data stored, etc. So we spend much of time in analyzing each of the steps in our architecture overview, and one of the simplest techniques that can help us is the STRIDE. STRIDE is a mnemonic for spoofing, tampering, repudiation, denial of service, and elevation of privilege. The technique is used for identifying threats in these 6 areas. It's actually another taxonomy for the famous triad, the CIA, the confidentiality, integrity, and availability. So the ultimate goal of STRIDE is to go through the process and start asking ourselves, how can someone spoof his identity? How can someone tamper our data? And how can we make sure that there is no repudiation in place? How can information be disclosed, and how can someone take advantage of some vulnerabilities to provide a denial of service? And how can someone access the system in an unauthorized way? And many mitigation approaches exist, such as using passwords, multi-factor authentication, and digital signatures to protect against spoofing attacks. And we can use permissions, access control lists, and again, digital signatures to protect against data tampering. We can use secure logging, auditing, and digital signatures, of course, to protect against repudiation. Encryption, access list controls as well can be implemented to protect against information leakage. Permissions, access controls, quotas, for example, some filtering techniques can be employed to protect against denial of service, and least to protect against elevation of privileges, we can implement the techniques of input validation and access controls. I'm sure you've heard about the famous Wireshark network sniffing tool, which is used to understand protocols, debug issues on the network, and of course analyzing traffic. The Wireshark uses the libraries on Linux and Windows called libpcap and wimpcap, Linux packet capture and Windows packet capture. As you might have seen before, if you use this tool, you will get lots of traffic. So the secret to effectively use the tool is to use the capture and display filters. So before demonstrating how Wireshark works, let's go back to basics and see how we establish a basic TCP connection. So actually, when there's communication between the client and a server, the client sends a SYN packet. The server replies back with a SYN ACK packet. Then the client confirms back with an ACK packet, and here the connection is established. So this is a full round of TCP connection. You might have seen that the server always replies with the sequence number +1. Then the client replies with a previous sequence number +1. No need here to go into the details, we're just explaining that in order to make an effective use of the Wireshark. Similarly, the same thing goes when we are terminating a connection, a three-way handshake as well. So the client sends the server a FIN packet, then the server replies with a FIN ACK packet, then the client confirms with an ACK packet, and the connection is terminated. What we will demonstrate here in the next live example is this scenario. From our Kali machine, we will connect using our previous example, the netcat, and we will try to use the previous example of texting using the chatting between the client and the server. Then we will fetch the traffic and analyze the traffic and see what happened. So here, if you want to open Wireshark, you go to the menu under sniffing and spoofing. First of all, you need to filter the interface that you want to capture traffic on. If you can see here, by default you have lots of filters, and if you capture all the traffic coming on these filters, you'll end up with a huge amount of data and information. So we're interested in only filtering or using the wired interface, which is basically the Ethernet interface. So after that, we press on the start capturing packet here. It is very important to understand the layout of the Wireshark. It is divided into 4 parts. The lower part here is the network. As you can see, it's a low-level data, hex data, bits, etc. The upper part here is the capture filter. So based on the filter that we identified before, the capturing is taking place here. This section here is the capture engine. It's actually capturing the traffic based on the capture filters we defined before. And on top here, you will see the display filters. After we stop the packet capturing, you will of course end up with a huge amount of data. And this is the best way on filtering and querying the data that we will end up with. Now it's working fine and it's sniffing the traffic. We will go to the cloud server here, netcat, and we will invoke this command. So here we will open port 2222 and we will listen to any traffic coming on port 2222. From our Kali machine, we will open a terminal and we will invoke this command, which is an netcat, then NV option, then the target IP address, and then the target port. Now we were able to establish a connection between Kali machine and the Windows cloud machine. Remember the chat example we did before? Let's do it here all over again. Hello from Kali. Then we go to the machine here. We will see the text prompting. We can reply back, and if you go here to the Kali again, we will be able to see the message. So now a certain activity has been taking place between the client and the server. Now we can go here to the Wireshark and stop the packet capturing. This is a small file, but in the real world scenario, you might end up with a huge amount of data here. So these display filters will help us a lot in working with the file. We can filter based on the source address, the destination address, the protocol type, and the port. For example, if you can go to, just press ip.source, and the source here in this case is 211.130, and you press enter, you'll be able to get this information here. If you want to search on the destination 173.248.132.230, here you go. As you can see here, the data contains R protocol, NBNS, another R protocol, then TCP protocol, etc. If you want to filter on the TCP protocol, just write here TCP and then press enter. You will see here what happened actually in the previous example. The Kali machine with the source IP of 130 initiated a connection with our cloud server here. As you can see, this is the start of a three-way handshake. This is the SYN packet, and then the SYN-ACK packet, and then the ACK packet. Then connection has been established. If you want, you can follow a stream in order to get the cream. So if you right click here and then follow TCP stream, it will actually give us the end result of actually what happened in this connection here. Now if you start capturing packets again, suppose that I don't want to save this, and go here to my Kali machine and stop this connection, I'll stop the traffic again and filter again for TCP. You will see the three-way handshake for terminating the connection. SYN, ACK, and then the ACK packet.